Next, we are going to talk about some terminology in geometry. That is one of the topic a lot of students seems to struggle with, and we will cover half of the geometry in exam 2 and then another half for exam 3. So first one is point. Talking about a point, we have no dimension, length, or width, but it does have a location. For example, we can say this is point A. That's the location, and that represents point A. The second one is line. A line, the definition is a straight line that extends infinitely in two directions. So usually it will end with arrow on both sides like that. And we can call this AB. The notation for that could be a double side arrow line like this with AB here, or you can call this B to A. So the order doesn't really matter. Right? Okay, the next one is ray. So the definition is a line with an endpoint and extend to another direction infinitely. This one will have one endpoint and then point out and extend forever to the other side. I can call this AB. And be careful with this one when you do the notation because it has an endpoint, so the order does matter. So it will be like this. AB, and it's not going to be BA because the endpoint is at A, okay? So this is wrong. All right, so far so good. And the next one is line segments. Like normally when we talk about line, actually we mean line segments because line segment is going to be a line with two endpoints. I can have an endpoint here A, extend to here endpoint B. So the notation is going to be, you can either write a bar with AB or BA. Because this time both sides have an endpoint, so the order doesn't matter. Next, we are going to have intersect lines. For intersect lines, it's going to be two lines have one point in common. When they talk about line, they supposed to extend forever, right? Both sides, but they intersect at one point. I can name this AB, and this is CD. I can say the line AB intersects with CD. So notice the notation for line is double arrow both sides because they're supposed to extend in the space forever. Next, we're going to have transversal. And the definition would be if you have two lines and then there are a third line that cause both of them. In addition to naming it with two capital letters, we can also name a line which extends to both sides forever with a lowercase letter. So I'm going to say this is X, this is Y, and this is Z. Is a line that causes at least two other lines here, right? So this one is transversal. Okay, and we have the line Z is a transversal line that causes line X and Y. Okay, so this is a line causing two other lines at least. So we are moving on to some relationship between lines. We have parallel lines You have two lines that will never intersect each other. So example can be A, B. It's not very good, sorry. So they should be parallel and never cross each other. Or we can have pointing up like that. I can say A is parallel to B. Or C parallel to D. I know my line is not very straight. Sorry about that. Let me fix it a little bit. So they are parallel lines. And next we are going to have perpendicular lines. So perpendicular lines is going to cross each other and intersect to form a right angle. And a right angle means there's a 90-degree angle. I can have something like this and this form a 90-degree angle. I can call this E and F. And let me try my best to do a sideways one. I didn't do a very good job. C, F, G, H maybe. I can say E is perpendicular to F. Is the symbol for perpendicular, and my G is perpendicular to H. Are we okay? Parallel lines are two lines never cross each other, never cross each other. Perpendicular is they cross each other and they form a right angle, means a 90-degree angle. And then we have concurrent lines. So concurrent lines means three or more lines intersect at the same single point. If I have three lines and they cross at the same point here, I can call this A, B, and C, and then they have one point crossing in common, so I can say lines A, B, and C are concurrent. All right. Next, we have collinear. This means a set of points that lie in a straight line. So if I have 3 points like this, and then a straight line can cross through them, that's collinear. These points are collinear. So these points A, B, and C are collinear. And if I have 3 points look like this, we can say these 3 points are not collinear. To be collinear, they can be lined up and you can use a straight line to go through all of them, but if you cannot use one straight line to go through all of them, these points are not collinear. Okay? All right, let's look at the next page. Okay, next we're going to look at some angles. The first one say the union of two weights, weight have one endpoint, right? Have a common endpoint called vertex of an angle. For example, we can have a weight go up here like that, and another weight go up here like that. There's an endpoint. So this is the common endpoint here. We call that vertex. And inside here is the angle, and the two way we can call them side. The endpoint here is vertex. Inside this part is the angle. The angle and the two way are considered side. All right. So I can have another example for you. If I have this, and call this A, BC, and this is a 1 here. I have a weight of BA and a weight of BC, and then they have formed a vertex, and we can call this angle ABC like this, ABC, or you can call this angle 1 inside here, ABC or angle 1, but you cannot call this angle B because we don't know it's outside here or inside there. It's not clear. You cannot do BAC. It's like BAC. The angle part has to be in the middle. ABC like that. ABC is okay. Or angle 1, which is labeled inside, is okay. These two are not. You cannot call this angle B. You cannot call this BAC. All right? Angle ABC or angle 1. You cannot call this angle B because we don't know if it's inside or outside. We cannot call this BAC because this, you have to make sure the middle letter is where the angle is. All right. Okay, the next one is called acute angle. This angle is going to be greater than 0 degree but less than 90 degree. It has to be between 0 degree and 90 degree, so less than 90 degree. All right, usually it's less than a right angle like that will be considered as an acute angle, and that one of the teachers say is a acute angle, so it's kind of tiny. That's how we remember it. Tiny acute angle, CUTE. All right, the next one would be wide angle. Hopefully you know this one. This one is a 90 degree angle. This angle will equal to 90 degree. So it will form a 90 degree here to be considered as a right angle. So for some reason I'm missing one, the straight angle. So help me to add one. A straight angle is going to be, for the definition, is going to be a 180 degree angle. An example will be, it's going to form a straight line here. So this will be a 180 degree. And this would be 90 degree. We added one more angle, which is straight angle here. Next, we're going to have obtuse angle. Obtuse angle is going to be bigger than 90 and less than 180. It's going to need to be bigger than 90 degree and less than 180 degree. Something bigger than a wide angle like here, or we can do one like this. Also would be bigger than 90 degree and less than 180. And the next one is called an adjacent angle. It's going to be angle that share a common weight as one of their side. So if I have something like this, I have angle A here and angle B here. They share a weight. Angle A and angle B are adjacent next to each other, right? Angles. All right. So as long as they share a weight, they are considered as adjacent angle. And then we have complementary angles. Complementary angle is started with a C, so I use that to help me to remember that. It started with a C, is related to something look like a corner, which is 90 degree. This one say the two adjacent angle, if you add up the degree, it equal to 90 degree, kind of like this guy. If you have a wide angle and two of the adjacent angles, so say this is C and D. When you add them up together, they are going to be 90 degrees. So angle C plus angle B here equal to 90 degree. Angle C and angle B here are complementary angle. They add up, look like a corner, right? And then we have supplementary angle. So supplementary angle, the way I help myself to remember that is it start with S. It's going to look like a straight line with the S. Meaning when you have two adjacent angles and they will add up like a straight line 180 degrees. So for example, if I have a straight line here and cut it two angles, I can call this E and F, angle E, angle F. If we add them together, angle E plus angle F would be 180 degrees because they form a straight line. The two angles are supplementary to each other. Supplementary angles. Okay? One add up to a corner, 90 degrees is complementary. One add up to a straight line, which is supplementary. And then we have the reflex angle. So the reflex angle is going to be an angle that is more than 180 degrees, but less than 360 degrees. So if I have something like this, and the outside angle here, I can call this C, this so, and then maybe I have something like this. Again, the outside part like here, we can say angle C and angle D here are reflex angle because both of them are bigger than 180 degrees but less than 360 degrees. All right. The next one is angle bisector. What do they mean by that? Angle bisector. We are going to have an angle bisector is a way that divide an angle into two equal angles. So whatever angle you have, if there is a way in between, and then divide this into two angles, they have the same degree, same angle, same size angle, then we can call this ray as angle bisector. Angle bisector is a ray that divides an angle to two equal parts, and that ray is called angle bisector. All right, and we have some benchmark angle. We have benchmark fraction. Now we have benchmark angles. The benchmark angles, including the 90-degree angle, which we also call the right angles, right? And then we also have the 180 degree, we call that what? Straight angle. And a 360 degree represent kind of like a circle. And 45 would be half of 90, right? That would be half of a right angle. And 30 degree would be a third of this, right? So 1/3 of a right angle. And 60 would be double that, so it's going to be 2/3 of a right angle. All right, so we consider those as like special angle. They are benchmark angle. We are going to show you how to measure angles when you come back in class next time. So if you have a protractor, please bring protractor to class. I will have some that you can borrow also. All right.